Good morning.
Good morning.
All right, so let's see, where's Joseph City today?
We have a baseball game that's away, and so the two boys were released.
All right, and how about Offering?
Avron actually dropped the class yesterday.
Okay. All right. All right, so let's see, is Ellie there today in Holbrook?
I think she is, but she's taking the AZ merit testing right now.
Oh, that's right. Okay. Yeah, so isn't it going to be over pretty soon though?
Yeah, but some kids are still testing, I think.
Okay, all right. So like the slower kids, right? Just kidding. All right. All right. How about in Winslow? It looks like everybody's there. Is everybody there in Winslow? Yeah. All right. So, did you guys have to do testing this morning?
Yes, they had more testing, so this is a double class right now.
Oh,
Their
okay.
schedule's all mixed up.
So are those people in the back with the computers? Are they actually like doing the writing?
No, they're not taking tests right now. This is my actual first hour class,
Oh yeah, because
and it overlaps with the Talon.
the schedule is all mixed up. So they're gonna get some free math here today. So that's pretty cool. All right. Well, glad to have y'all here. Okay, so today, so I did update your midterm grades. So we did a 10-point curve on the midterm. So I went in and added 10 points to your overall score. And so if you want to see kind of how that affected your grade, you can do that. So today we're going to finish 9.2, and depending on the time, we might go into 9.3. I did send out the guided notes just a few minutes ago for 9.3, 9.4, and 9.5. So hopefully that'll keep us busy through the week anyway. So does anyone have any questions, comments, concerns before we get started? Okay, well, let's do it then. Okay, so yesterday we ended on this practice problem 1A, and so I had asked you to see if you could work through that on your own. So let's just kind of, if you didn't, take a minute and just see how far you can get. Let's just see what we can do here. All right, so Brooke, let's start with you. The first question is, what is the vertex of this triangle?
-1, 3.
-1, +3. Very good. So you have to change the signs just like we did with circles in the ellipses. So -1, +3. All right, great job. All right, next. Does it open vertically, up and down, or horizontally, left and right? So, Tiana, what do you think?
Vertically.
Vertically. Okay, that's right. Because, and how you know that it opens up and down, or vertically, is how? How do you know that? Just by looking at it.
X. Because that's the x minus h in the equation?
But yeah, because, well, it's the x is the one that's squared. Okay? So if the y part is the one that's squared, then it would open left and right. But since it's the x is squared, then it opens vertically or up and down. All right? The next question, what is P? All right, Dominic, what is P equal to?
I got one.
You got what?
One.
1. 1 is correct. All right, because, see, when you're calculating P, which is the directed distance between the vertex and the focus, that P, you calculate by the number in front here is equal to 4P. So in the equation, it's 4P equals 4. Or if this is 8, you would say 4P equals 8. Or if this is negative 12, you say 4P equals negative 12. Whatever. And then solve. So if 4P equals 4, then P equals 1. Okay, good. All right, the next question is the focus. What is the focus? All right, Shannon. What is the focus?
I forgot focus was.
Okay, so the focus, so once you have the vertex, and if we know the parabola opens up, then the focus is going to be up P units. So if the P is 1, if you add 1 to the vertex, 1 unit up. So are we going to add to the x value or the y value?
The y value.
Since it's up, we would add to the y value 1 unit. So then it would be what point?
Negative 1, 4.
Negative 1, 4. Okay? All right, now, I personally think the hardest question of these is to find the directrix, because you have to think of several things. But let's just see. So, all right, so Tiana, what would be the directrix for this? What's the equation of the directrix? So the line that's the same distance from the vertex.
I got 3.
3? Okay, let's see. So the line doesn't go through the vertex. See, y equals 3 would go through the vertex. So, and like I said, I think that this is a little tricky. So one of the things I do is graph it while I'm trying to figure out the directrix, because that always helps me. So even though graphing, it asks for that later, let's go ahead and graph what we have here. Well, okay. So we've got the vertex at negative 1, 3, right here. And then the focus is at negative 1, 4. So there's the parabola. So notice the focus is always on the inside of the parabola. Okay. Now, so we said that P was 1, so the distance from the vertex to the focus was 1. So then the distance to the directrix is also 1. So it's this horizontal line right here. So since we were at 3 for the vertex, if we go down 1, we're at y equals 2. So the equation then is y equals 2. So for the directrix, remember, if you have a horizontal line, its equation is y equals a constant. A vertical line has for its equation x equals a constant. Okay? And so then that's the graph. All right. Now, I'm going to add one more question. This is not on the sheet, but we talked about it yesterday. What's the equation for the axis or the axis of symmetry? So you can add that on there because I do expect you to know how to do that. So the axis of symmetry, and hopefully you can get that from the graph. All right, let's see. Is Ellie there yet? Nope. All right, so Shandon, what's the equation of the axis?
X equals -1.
X equals -1. Excellent. So the axis is this vertical line that cuts the parabola in half. And so it passes through the focus and the vertex. And so it's x equals the x coordinate of the vertex. So x equals -1 is the coordinate, is the equation of the axis of symmetry. Okay? All right, any questions on any of those? Anything you want me to review? All right, well, good job, everyone. Okay. Okay. Let's see, what are we doing here? Okay, so, all right, so at the bottom it says to find the focus, convert to standard form by, so if ever it's not, the parabola is not in standard form, then to put it in standard form, then we have to complete the square. So convert it to standard form by completing the square. So that's what goes on the blank at the bottom of the page. So in the next problem, we're asked to do the same things again, like on the last practice problem. The difference is that now this one is not in standard form. Okay? All right, so all right. So let's say we start off with something like this. Okay? So to put it in standard form, we have to complete the square. So the y is squared, so that's the one we're going to complete the square from. So we're going to, first thing we're going to do is, when we complete the square, I like to have the square term positive. So here, multiply everything through by -1. All right, then get the y terms together on one side, and then everything else on the other side. Okay? Now, we're going to complete the square here. So what would I add to the y's to make this side, this left side, a perfect square? All right, somebody's about to say something really smart here. Come on, just what do you add to complete the square on the left? Remember, it's half the middle term. That's what this is saying over here. It's b divided by 2 squared. So what's the b here?
Is it 1?
Yeah, so -2 divided by 2 is -1. -1 squared is +1. So I'm going to add +1 to both sides. Okay? So now this is a perfect square. It's y minus 1 squared. And then over here I add the 5 and the 1 and I get 6. All right, now I've almost got it in standard form. The difference is that this side now, we've never really had to deal with the other side, but see, you don't want to have a number in front of the x. So we're going to factor out the 2. Because to get the vertex, it's going to be hk. So we factor out a 2, and we're going to have y minus 1 squared equals 2 times x plus 3. Okay, so that is the standard form. All right? Next, if I want to know what is the vertex, all right, then again, I changed the signs, but the h still goes with the x and the k goes with the y. So the vertex is not 1, -3, but it's still -3, 1. So that's a little tricky if they're not in because they're in a different order. But the vertex here is -3, 1. Okay? All right, the next question. Does it open vertically or horizontally? What do you think? Just looking at the standard form.
Horizontally.
It opens horizontally, and how do you know that?
Because the y is squared.
Because the y is squared. Great, great. Okay. All right, then let's see, what is p? So whatever this number here in front, you set that equal to 4p. Okay, so if 4p equals 2, then p is equal to 1/2. Okay. Probably should. All right, so p is equal to 1/2. All right, then let's see. So find the focus. So then if our vertex is at -3, 1, so -1, 2, 3, 1 right here, then our p is 1/2. So we go 1/2 unit to the right, and then it opens up to the right. Because the focus is always on the inside of the parabola. Okay? So then what would be that point? So if p is 1/2, let's see, I'm at -3, 1. So if I add 1/2 to that, whoops. Then the focus is -2.5 or -5/2, however you want to put it, +1. And then to get the directrix, okay, so then the directrix we're going to move 1/2 unit to the left. And so it's going to be, let's see, we were at -3 minus a half. So -3/2, 3.5, or -3.5. And so it's a vertical line. So it's x equals -3.5. And then I'm going to go ahead and add another question here, is what is the axis? Okay, so the axis is a horizontal line now that goes through the vertex and cuts the parabola in half. So since it's a horizontal line, it's y equals, and then it's the y coordinate of the vertex, which is 1. So y equals 1 is the axis of symmetry. So it'd be kind of like that. Okay? All right, any questions on that? All right, so I'm going to leave this up to remind you of the steps to complete the square, and then I would like you to do practice 1B.
Mr. Strong,
Yes.
how do you know which way the graph opens, like vertically?
Okay, great question. So let's say it's because of where the focus is. The focus is always on the inside of the parabola. So let's say that you know that your parabola opens up or down. Well, if your focus is positive, if the P is positive, then that means that from your vertex, the P would be positive, so you would go up for the focus, and so it would go like that. If the P is negative, you would go down for the focus, and then it would open down. All right, so now let's say it's a sideways opening parabola. So you find your vertex. If the P is positive, you go to the right, and so it would open like this. If the P is negative, you would go left, and then the graph would open like that. So you find the focus, and the parabola always goes around it. The focus is always on the inside.
Okay, thank you.
You bet. Thank you for the question. All right, so any other questions before you do practice 1B? Okay. Okay, so Alana, what is the standard form of that parabola?
I got stuck.
Okay. Let's see, where did I do that? Let's see, nope. Okay. Let's just work it down here. Okay. So to put it in standard form, there's nothing to multiply through or factor out. So what we want to do though is get the y's on one side and everything else on the other. Okay. All right, now we're going to add a number here to complete the square. So, Alana, what will I add here to complete the square? Okay, the number in front of the y, we call that b. Okay? So that number, the coefficient of y is -4. So you take half of that. So what would half of that be?
-2.
All right, and then square that.
4.
4. So that's what you add to both sides to complete the square. So it's you take half the middle term and square it. Okay? So that's what you add to each side. So now this is a perfect square. So what is it? What's the perfect square of that?
2.
So y minus 2. So it's always half that middle term before you square it. So y minus 2 squared equals 8x plus 8. Okay, so the left side is good. Now, the right side, if ever you have a coefficient in front of the x, you have to factor that out. So we have y minus 2 squared equals, so factor out an 8, and we have x plus 1. So that's the standard form of the vertex, of the parabola, excuse me. Okay, so y minus 2 squared equals 8 times x plus 1. All right, so Dominic, what is the vertex of that? I'm sorry, you got cut off there.
-1,
-1, 2. That is correct. Okay? Because it's the h goes with the x, the k goes with the y. So take the opposite of each number in there, -1, 2. All right? Good job. Okay, so does it have a horizontal or vertical opening? All right, Cameron. Does it open horizontally
Vertical.
or vertical? No. It opens horizontally. It opens vertically when the x is squared. Okay? Just like the very first parabola that you ever studied in Algebra 1 was y equals x squared, and that opened up. It opened vertically when it's x squared. When it's the y squared, then it opens horizontally. So sideways. And see, you didn't even study those in Algebra 1. Okay? All right, next, the P. All right, so Dominic, what is P?
Two.
2. So you say 8 equals 4p, so p equals 2. Good. All right, next, the focus. All right, so Cameron, what is the focus of this parabola? So we've got the vertex.
Would it be 0, 3?
No, because it's a horizontal. So when you have the vertex, you count over 2 to the right because the p is positive. So let's see, that would be, so 1, 2. So from this point right here, if I'm going to move 2 to the right, see, then I don't touch the y value.
So it'd be 1, 2 then?
It would be 1, 2. Okay, good. All right, next, the directrix. All right, Shandon.
-3.
Okay, so what did so is it x equals -3 or y equals -3?
X equals -3.
X equals -3. Great job. Because you have your sideways parabola, so the vertex is going to be a vertical line. The directrix is going to be a vertical line. So it's going to be x equals, and so you go in the opposite direction. Okay? And so then to look at the graph, okay, so here's our vertex is at -1, 2. Our focus is 2 units to the right, so the parabola opens to the right. And then our directrix is 2 units to the left, vertical line, x equals -3. Great job. All right, so let's add one more then. So what is the axis of symmetry? Well, these guys have been picked on a little bit. Cameron, what is the axis of symmetry for this parabola?
Y equals 2.
Y equals 2. It's the y coordinate. It's y equals because it's a horizontal line and it passes through the y value of the vertex. So y equals 2 is correct. Okay. All right. Great job. Any questions on any of that? So you can see I could do a quiz for this section just on one problem because I've got enough things I could ask you here. Okay? All right. Oh, I was wondering where that was. Okay. Okay. So this says given a directrix is y equals 2 and that p equals -1 and that the parabola is symmetric with respect to the line x equals 2. That means that's its axis. Find its standard form. Okay? So let's see if we can kind of puzzle this together. The key to this is figuring out the vertex. So one of the things I like to do, just like when we did with the ellipse, when we were given little clues like this and trying to find the standard form, one of the things I like to do is to graph it all. Okay? So I'll say, okay, so the directrix is y equals 2. So we start with that. All right, and p is -1. So that means that the distance from the vertex to the directrix is +1 because the distance down to the focus is -1. It's directed distance. So that means the vertex has to be down 1, okay, from that line. Now, since it's symmetric to x equals 2, then I know that the x coordinate is 2. So it's down 1 from this line, but the x coordinate is 2. So that gives me a vertex of 2, 1. And then if I go down another 1, that gives me a focus of 2, 0. All right? Now, so from that, I actually have enough information to get the equation. So it's going to be, remember, it's going to be x minus h squared equals 4p times y minus k, because it opens down. All right, so x minus, so the x coordinate of the vertex is 2, so that's going to go in for the h. The p is down 1, so I put a -1 in for p, so that'll be -4, and then y minus the y coordinate of the vertex, which is -1. Okay? And so that's it. That's the answer. And so let me just kind of remind you, the same thing I told you when we were doing these ellipses, is that as a student, I never thought, I always thought these were really hard because I thought that they weren't giving me enough information. But what you need to do is graph what you have there, and then you can kind of, from the graph, figure out what you need to know, like where the vertex was and so on. Okay? So in practice 1C, they give us the directrix and the focus. So see if you can graph those. It's going to be a little different than this one. So I'll just go. So go ahead and do practice 1C. All right, anybody want to volunteer for this one? Anybody think they've got it? All right, well, again, let's go through the graph here. Okay, so the first thing I do is graph the focus at -2, 1. So there's the focus. Okay, the directrix is the y-axis. So that means this vertex has to be exactly in between. So that would be at the point -1, 1. is halfway between the focus and the directrix. All right, and then since my focus is to the left 1 unit, that means the P is -1 because I went to the left.
Mr. Strong,
Yes.
on our paper it says -2, -1 for the focus.
Oh, focus. Yeah, the focus is. The focus is -2. Oh, -2, -1. Ah. Okay. Well, just change it to -2, +1. I'll make a note of that. So that's my fault. Sorry. Okay. And so now since it goes sideways, then it's the y that's squared. Okay. So this is gonna be the standard form of the equation because it's the y part that's squared. Okay. And so now you just plug in -1 for h, -1 for k, or +1 for k, and -1 for p. Okay, so the answer is going to be y minus 1 squared equals 4 times -1 times x minus a -1. Here, let's go ahead and include that step. So x minus -1. And then when we simplify that, we'll get y minus 1 squared equals -4 times x plus 1. So that would be the equation in standard form. All right. Any questions on that? Okay. Well, so the last thing we want to do here is do what we call an application of parabolas. And so, like, if we have like a parabola in 3 dimensions, does anybody know what that's called? It's called a paraboloid. Paraboloid. Okay. So, like, anytime you use like a satellite dish or when you see those guys on the sidelines of football games and they're holding like a big dish, that's a paraboloid. It's a 3-dimensional parabola. And so what it does is it takes the signal that's sent and it is built in such a way that there's like a microphone that's in the center where the focus is of the parabola. And so it bounces those sound waves or light waves or whatever, and then it sends that then to the receiver or whatever. Okay? And so the idea of a paraboloid and a focus is extremely important in a lot of technologies. Okay? All right. So in this example here, it says the Hale telescope at Mount Palomar Observatory in California is a very large reflecting telescope. The paraboloid is the top surface of the large cylinder of Pyrex glass 200 inches in diameter. So that's just the paraboloid part. Along the outer rim, the cylinder is 26.8 inches thick, while at the center, it is 23 inches thick. Where is the focus of the parabolic mirror located? Now, it doesn't seem, again, like we have enough information here. But what really helps is you start graphing what you do have. Okay? So what you do is you kind of imagine this paraboloid being on the XY axis. And so you put like the vertex at 0, 0. All right? So now it says that this distance up here is 3.8. Well, it didn't give us 3.8 in the problem. We actually calculated that. Let's see, how did we do that? Well, it's, whoops. So we're told that the outer distance is 26.8 and the inner distance is 23. So if we subtract, here, that's a little confusing there. Let's redo that. So if we subtract 26.8 minus 23, then the distance is 3.8. So that means the middle part is 3.8 inches lower than the outer side. So that's why we get 3.8 here and here. Now, the other advantage to putting it on the coordinate axis is that we can say, okay, it says this distance here is 200. So we can call this 100 and this negative 100. And so the whole purpose of that is so that we can figure out what the standard form here is, and we can figure out what P is, and then we can figure out where the focus should be. Okay? So by putting our vertex at 0, 0, then the beauty is that this simplifies to just here, let's rewrite it over here. So it's x squared equals 4py. All right. So then so now if we plug in one of these points, it should satisfy the equation. If this point 103.8 is on the parabola, we could do 100 squared equals 4p times 3.8. So then that gives us 10,000 equals 15.2p. And so then if we divide both sides by 15.2, we get P equals 657.9 inches. And that in feet is 54.8 feet. 54.8 feet. So that might seem like a lot, but so this is a huge telescope. And so this is the lens, and so we put the focus up 54.8 feet. So that's why if you've ever been to an observatory and they have these huge telescopes that can see, all over the solar system and beyond. I mean, that's a huge, we're reflecting a lot of light into that focus. And so that focus is going to be 54.8 feet. Okay? All right. So let's see if you can do practice 2. So see if you can draw it up. And then, so let's see. It says one design for a solar furnace is based on the paraboloid found by rotating the parabola x squared equals 8y around its axis of symmetry. The object to be heated in the furnace is then placed at the focus of the parabola. Okay, so, and then it says, where is that? So what we're wanting to do here is find the focus. Let's see, where is it? So see if you can kind of draw it out and find the focus. All right, so Junior, can you tell me where the focus would be? Okay, what's P?
Two?
Yes. So if it's 2, then if this is the vertex is 0, 0 for this equation, so then if the focus is, the P is 2, then we count over 2, and so then the focus would be at 2, 0. So then the hottest part of the furnace is going to be 2 feet from the vertex. Okay? So when you're designing that solar furnace, you that's where you want to put the food that you're cooking. Okay? So you design that solar furnace and then you put the food there because then the sun's rays will hit the paraboloid, the solar furnace, and cook it. And so if you don't put it at the focus, then it's not going to cook as effectively or as quickly. Okay? So you want to put it at the focus, so that'll be at 2 feet over, so at 2, 0. All right? Okay, well, obviously we don't have time to start the next lesson, but we finished 9.2 today. We'll start on 9.3. I'll post a quiz for 9.2 this afternoon or tomorrow morning. Okay? So good luck, and we'll see you on Thursday. Don't forget about tutoring tomorrow if you need it. Okay? All right, you guys have a great day.